All right, this is 2.2 standard form of a quadratic function. You know that doesn't say 2.2 anywhere on it, does it? Let me put 2.2 here and hit save real quick before I do any typing. 2.2 standard form of quadratic function. The I can statement, it is write and graph quadratic functions that are in standard form. And you know, it seems like there's a prereq page here. Ah, the prereqs, the vertex form of quadratic. Vertex form, I love it. You should too. Vertex form of a quadratic would be that f of x or y or whatever you like is a times x minus h quantity squared plus k. Okay, so example, graph this thing. So I'm going to do a line up process. You see how I do that? I'm going to line up. And we're supposed to graph. It's going to be a freehand graph. I've been up since about 4, so I'm already on a couple energy drinks and I'm already jittery. All right, this means right 3, up 5. Right 3, up 5. Put me a dot right there. Now, I'm also going to draw in the axis of symmetry. I don't know if you remember that or not, but that was the whole right 3 thing. It's at x equals 3. Now, this is A. This is my initial slope. And since it's 4, it means rise 4, run 1. So I need to rise 4 and run 1. Now, I have to do it both ways, and maybe the axis of symmetry helps you realize that, but if I have something 1 unit to the right, I got to have something 1 unit to the left because I'm trying to draw a parabola, right? And there we go. This is vertex form. And you know, while we're at it, why don't we talk about domain? The leftness to rightness. It is negative infinity to infinity. And the range, which is the downness to upness, it has a low y value of 5, and it rises on either side of the parabola to infinity and beyond. Why don't we also talk about this? The minimum. If I could spell minimum this morning. The minimum is a y value of 5. And that's happening at the vertex, by the way. Vertex is a big deal. All right, so back to 2.2, the standard form of a quadratic function. What is the standard form, the STD form of a quadratic? Well, that would be the ax squared plus bx plus c. So standard form would be f of x or y equals ax to the second plus bx plus c, where a is not 0. That's the big deal. A can't be 0, because if a was 0, it wouldn't be a quadratic because it wouldn't have x to the second. And again, as a reminder, I know something is a quadratic, and I have to keep saying this because the number of kids who can't connect the dots between being a quadratic and what they see on the equation is kind of ridiculous. It's horrible. I know something is a quadratic if we'll say the biggest term is x to the second. Okay, the leading term is x squared. That's what I'm looking for. All right, so Jordan and Emery are rewriting the vertex form of the quadratic function. Y equals 2 times x minus 4 squared plus 5 in the form of y equals ax squared plus bx plus c. And you can see Jordan's work, and you can see Emery's work. And if we were in class right now, I'd let you guys study this for about a minute. So hit the pause button. And I want you to figure out who's right, because they're arguing about who's right. And usually what happens in class is about half the kids pick Jordan, about half the kids pick Emery, and only a handful actually get it right. They're both wrong. They're both 100% wrong. First off, this move, PEMDAS. What he should have done was 2 times x minus 4 times x minus 4. If something's squared, you write it twice, and he should have done some work with that right there. Emery? Poor Emery. I guarantee you Emery has failed every math class that she has ever taken. I guarantee you that. Poor Emery. Bless her. I've got a little meme here off to the side. Every time you do something like that, a little puppy dies. Look at that little puppy. It's so cute. Poor Emery. It's kind of sad like Emery. It's probably sad for Emery's sake. Not the fact that, something happened to it. It's probably sad for her. But they're both dead wrong. I would argue that Jordan's a little more right because at least Jordan actually did do some work. Jordan squared 2x minus 8 properly. But they are both wrong, okay? So 2 times x minus 4 squared is twice x minus 4 times x minus 4, which is 2x minus 8 times x minus 4, or it's 2 times x squared plus 8x plus 16, because we can FOIL, right? So they're both dead wrong. Anyways, you should probably write some of that down. Moving forward, find the vertex from a quadratic function in standard form. So how can you find the vertex of a quadratic function in standard form? First thing you do is you identify the coefficients a, b, and c. So let's do the lineup process here. This is ax squared plus bx plus c. Now, come Friday, there's going to be a whole bunch of y'all can't figure out a, b, and c. Everything has an understood 1 in front of it, so a is 1. B, signs are a big deal. It is negative 6, and c is 10. Kids usually get c right. They do. It's the only one, but whatever. Solve for h, the x-coordinate of the vertex. So to do this, you're going to need a formula. So here's a formula, all right? The x-coordinate of the vertex is simply opposite b over twice a, and this should be the second time in your life you've heard this. You should have talked about this in Algebra 1, because it is an Algebra 1 skill. So b is negative 6. We're going to be negative b over twice a, and a was 1. Now, when you negate a negative, you get a positive, right? And you end up with 3. So what you have here is you have an x value. To get the y-coordinate of the vertex, you plug x in. So the y, and there's a formula for this too, but we're not going to talk about the formula. We're just going to take our number and we're going to plug it into the original equation. And then we're going to do some math, right? 3 squared is 9. 6 times 3 is 18. We're going to add 10 back. And it's this kind of stuff that hurts kids, and it's not supposed to be. And you get 1. So my vertex is at 3, 1. There you go. Easy peasy lemon squeezy. It really is. It's really quite easy. But some of y'all struggle. Alright, so here the goal is to graph f of x equals x squared minus 4x plus 12. Step 1 is to find the vertex and the axis of symmetry. And there's other ways of doing this, but we're going to follow this textbook. So again, the x-coordinate of the vertex is at opposite b over twice a. Memorize that. Put that in your heart right next. Just put it in your heart. Of course, we got to pick out a, b, and c. A is 1. B is negative 4. It's not negative 4x. It's just negative 4. And c is 12. The same kids who have a hard time with y equals mx plus b, they have a hard time picking out a, b, and c. They do. Alright, so opposite of a negative 4 is a positive 4. We're sitting over twice a, which is 1. Remember that was negative 4. So that's 4 over 2, which is 2. If we want the y-coordinate of the vertex, we take that 2 and we just plug it in every time we see an x. So it's going to be 2 squared minus 4 times 2 plus 12. That's going to be 4 minus 8. Add 12 back. That's going to be 16 minus 8, which is 8. So I know that my vertex is at 2, 8. Now, let me jump back to where I did this guy. See how my vertex here is at 3, 5? Axis of symmetry is at x equals 3. It's the x-coordinate of the vertex. We'll make a little note here. let me type that so you can read it, right? The axis of symmetry, the axis of symmetry is always, it's not sometimes, it's always the x-coordinate of the vertex. So therefore, the axis of symmetry, the AOS, well, we just write it out. You guys may not understand what that means, even though you've seen axis of symmetry. The axis of symmetry is literally x equals 2. Ta-da! All right. I have not done step 2 yet, and step 2 is kind of optional, but there's things we can do. So the question I'm asking you, and I'd like you to think about it a second, is how do we find a y-intercept, right? How do we find a y-intercept? Well, it's simple. You let x equal 0. So the y-intercept is going to be found whenever x happens to be 0. And we get 12. No surprise there to me. It's always going to be this last number if you're in the standard form. But we get a 12 back. Step 3 is to find intercepts if easily done. So x-intercepts, and again that's kind of the question here, is how do we find x-intercepts? Well, we do the opposite of how we find a y-intercept. We let y equal 0. So we're going to take our equation and we're going to set her equal to 0. So 0 equals x squared minus 4x plus 12. And then we're going to do our favorite F word, which is to factor, right? That's your favorite F word? I hope so. Factors of 12 would be 3 and 4 or 6 and 2. And I'm going to use 6 and 2 because I know that negative 6 plus 2 is negative 4. I'm going to use ZPP, zero product property. By the zero product property, x minus 6 is a 0 or x plus 2 is a 0. So x is going to be 6 or x is going to be negative 2. Now, these ordered pairs happened when y was 0. So I got negative 2, 0 as an ordered pair, and I also got 6, 0 as an ordered pair. So I have lots and lots of cool stuff, and I can actually graph it now, and we're going to, because why not? Because that's kind of the point. Graph a quadratic in standard form. And we're going to throw a lot of stuff on it, okay? I have an x-intercept at 6. I have an x-intercept at negative 2. I have a vertex at 2, 8, which is kind of high. Well, that doesn't make much sense. Well, that doesn't make a lick of sense there, does it? Oh, have I made a mistake somewhere? If I plug in a 2, 4 minus 8. I have made a mistake. Oh, Lord. Hopefully you caught that. Negative 6 times 2 is negative 12. I had a positive 12. This does not factor. There are no x-intercepts. So what I was catching here was that I had a vertex up here at 2, 8, but this thing's positive. It should be opening up. So let's scratch this. We don't have any x-intercepts. We have a vertex at 2, 8. About right there. What do we know here? Y-intercepts. We have a y-intercept at 12. 9, 10, 11, 12, about right there. And we have an axis of symmetry at x equals 2. Now, this y-intercept is 2 units to the left of the axis of symmetry. So by symmetry, there should be something 2 units to the right. Let me pause that. My wife is tearing me up over here. Something's up. Alright, sorry about that. I'm back. And you got to see me make a mistake. You'll never hear me say that I'm a perfect person. Obviously, I am very flawed. And that's what makes me a good teacher. I'm real. Alright, interpret the graph of a quadratic function. The graph of the function f of x equals negative 10x squared plus 700x minus 6,000 shows the profit the company earns for selling headphones at different prices. What is the maximum profit the company expects to earn? So the whole point of this slide is to help you realize that a maximum is going to happen right here. What do we call that point? What do we call that point of a parabola? Now hopefully, you're thinking and you say it's the vertex. We call it the vertex. And that's kind of an idea here, is that the maximum or the minimum, and you need to be writing notes, of a quadratic always happens at the vertex. And how do we find the vertex? Well, there's a formula for that. The x-coordinate of the vertex is, and it's a formula, opposite b over twice a. I use parentheses here because I'm writing sideways. You have to have parentheses. Hopefully you understand why, but you do. It's always at opposite b over 2a. Now, the problem with the graph is I don't have an exact number. I think it's probably around 35 and maybe $6,100, okay? If I was just looking at a graph, I might guess, this is a guess, that's around 35 and around $6,100. But I don't have to guess, now do I? Because I have a formula. I'm pretty sure the 35 is right. I'm pretty confident in that. But let's plug into opposite b over 2a. So opposite of a positive 700 is a negative 700. And sitting over twice a negative 10. So that's going to be a negative over negative is a positive, 700 over 20, which is 35. I guessed that properly. So the maximum happens when I sell, my selling price is $35. Okay? Now, this is the max price. This is the best price. The question wasn't the best price. The question was about profit, right? So to find the profit, we plug or substitute the price in. So let's see here. We're going to find f of 35 because we understand function notation. It's going to be negative 10 times a 35 squared plus 700 times a 35 and then minus 6,000. And very few of you will play along here. I'm actually a huge fan of what we call a storage feature. I'm going to take a 35 and I'm going to store it to x. Alright? And then I'm going to type in the original equation. You have fewer typos if you use a storage feature. But what do I know? According to some, nothing. 6250. That's the maximum profit they can expect to earn. Not a very big business, to be honest with you. Hopefully that's in like thousands. All right. Esteban is training for the discus throw. His coach recorded the horizontal distance and height of one of Esteban's discus throws. The graph shows the horizontal distance the discus traveled in meters and the height of the discus in meters. What will be the height of the discus when it has traveled 15 meters from Esteban? Well, we would expect some symmetry to happen at some point in time. The question is this the maximum or not? Because what it's going to do is it's going to go up and then it's going to go down, right? That's the idea. It's a parabola, so that's the idea. We're going to do something called quadratic regression. So these notes are on the next page, but I'm going to go ahead and move them over here so you can play along. And you do need to play along. You don't have to recopy all this stuff. We're going to go to Stat. We're going to go to Edit. We are going to place our X's in list 1 and our Y's in list 2. Notice I'm hitting the clear key and not the delete key. I've used this thing. So I've got X values of 1 to 10. and then I'm going to put in the y values. And that's the general gist of these things. X is in list 1, y is in list 2. And you can read the instructions if you'd like. Now obviously if you don't play along on this, this was pointless, right? 100% pointless. I'm checking for typos. Alright, now to do this, I know this is a quadratic equation. I'm going to go to Stat, Calc, Quad Reg. I'm not going to worry about something else that's in those notes right now. Quad Reg, it's number choice 5, quadratic regression. I'm not worried about the R values. We'll talk about that at a later date. And here's my equation, and there's no way to convert those to fractions. But this is my equation, and I'm a big fan of taking things out to the nearest, you may or may not see R values, so don't worry about that. Not worried about it today. This is my equation. Let's round it out about 4 decimal places. Let's make this height as a function of x is negative 0.0271 x squared plus 1.0583 x and then plus 0.6722. Now if I want the height at 15 meters, I'm going to plug in a 15 and put a 15 everywhere I see an x. A little short on time. It looks like I got about 2 minutes before I have to let you guys in. So we have negative 0.0271. Oh, first off, my bad. Take a 15, store it to x. Negative 0.0271 x squared plus 1.0. Now, as big as a fan as I am of doing things in your head, let's be realistic on some things. 0.6722. That's why we're using a TI-84 for this. And it's about 10.4. How are they rounding in these things? Second decimal? 10.45. It is actually still on the path up, isn't it? So it's actually still on the path up, but around 10.45 meters. There's another one here for you guys to do. I'm out of time, but I mean we can do it real quick. And actually, why don't you at home go through the process of doing this problem? And again, that's what I'm suggesting you do. I'm suggesting you go to TI-84 or whatever you got, TI-84calc.com, and put the time in list 1 and the height in list 2, and go through the process that I just went through. And don't worry about this step. I'm not too worried about this one. All right, so don't worry too much about 3. But anyways, go through the process, see if you can come up with this equation, negative 16x squared plus 12x plus 10. And I ran out of time. Hopefully you try it. Can't make you though. See you tomorrow.